Third stage is go.
Roger.
Minus 40 seconds.
Stable at step 3.
Dow's locked.
CS reduced for launch. Roger.
Minus 25 seconds.
Status check.
Go Atlas. Go Centaur.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
The New Horizons spacecraft was launched in 2006 and became the fastest spacecraft ever to leave the Earth. After a gravitational assist from a flyby of Jupiter, the probe's speed increased to over 52,000 miles per hour. This maneuver shaved 3 years off its journey. Yet even at this speed, it has taken over 9.5 years for New Horizons to finally reach its primary target, Pluto. Trillions of objects inhabit the 3 realms of our solar system. The first realm consists of the innermost rocky bodies: Mercury, Venus, Earth, Mars, and the asteroid belt. The second realm is made up of the gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than their rocky counterparts. And the trillions of frozen objects beyond Neptune's orbit occupy the third realm. The third realm is immense, stretching billions of miles beyond Neptune. It is made up of 3 regions: the donut-shaped Kuiper Belt, the scattered disk, and the spherically shaped Oort cloud. About a century ago, Pluto was the very first object to be found in the third realm. The person who discovered this small, distant world began his astronomy career in a very inspiring way. A 20-year-old farm boy with a hobby of making his own hand-built telescopes carefully sketched out the features of Jupiter and Mars. He sent his observations to the Lowell Observatory in Arizona, hoping for some professional feedback. Instead, the staff at the observatory wrote back and offered him a job. On February 18, 1930, after 4 years of work at the Lowell Observatory, Clyde Tombaugh discovered Pluto, a faint point of light moving against the field of stars. Pluto was considered the 9th planet until several other bodies about as large as Pluto were discovered in the outer solar system. One of these bodies, named Eris, was estimated to be even larger than Pluto. Everyone expected that Eris would be named the 10th planet. Instead, its discovery sparked a controversy among astronomers. What exactly defines a planet? After some debate, a new set of rules were adopted, and Pluto broke one of them. it did not clear the neighborhood around its orbit. To be a major planet, an object must gravitationally dominate its orbit. That is, it should either sweep up or eject other objects in its region of space and thereby clear its neighborhood. Since Pluto shares its orbital neighborhood with other Kuiper Belt objects, it is now considered a dwarf planet. Even with Pluto's reclassification, our love for Pluto hasn't changed. That small fuzzy dot that Tombaugh pointed out a century ago is still a cherished member of our solar system. We have now traveled 9 years, 5 months, and 25 days. We are 3 billion miles from home. Our first close-up pictures of Pluto reveal a breathtaking world. Pluto is roughly 2/3 the diameter of our moon, and evidence suggests it has a rocky core. A frozen coat of methane, nitrogen, and carbon monoxide glaze its icy surface, concealing a mantle of liquid water kept warm by the slow decay of radioactive elements in its core. Pluto's surface has distinct light and dark regions. The lightest feature, named Tombaugh Regio, is the largest known glacier in the solar system. From the right angle, it looks like a giant heart. The western half of Tombaugh Regio appears to be an impact basin. This region is filled with chunky sections of frozen nitrogen, surrounded by narrow troughs which appear to be flowing. Since the basin has no visible craters, it is probably a relatively young feature. To the left of Tombaugh Regio is a large, dark reddish area that stretches almost halfway around Pluto's globe. This area is heavily cratered, suggesting it is very old. The red color is likely created by an interaction of atmospheric methane with UV light and cosmic rays. The compounds produced in this interaction then fall to the ground and form a layer of red gunk. 2 mountains with craters at their summits rise above Tombaugh Regio. They resemble cryovolcanoes, icy volcanoes that spew ices from deep underground. These mountains have only a few craters. They are likely older than Tombaugh Regio, but much younger than the dark reddish areas. While much brighter than the other stars visible from Pluto, our sun is only a shining point of light in Pluto's daytime sky. At this distance, light from the sun is comparable to the brightness of a full moon as seen from Earth, making Pluto a cold and inhospitable world. Pluto's orbit is unusual. While the major planets all share a common orbital plane, Pluto's orbit is inclined at an angle of 17 degrees. This carries it above and below the plane of the solar system. Pluto's distance from the sun varies significantly due to its eccentric orbit, which sometimes brings it closer to the sun than Neptune. Because it takes Pluto 248 years to go around the sun, each of Pluto's seasons lasts more than a half a century on Earth. Like seasons on Earth, the seasons on Pluto are caused by its tilted axis. But unlike Earth's 23.5-degree tilt, Pluto is tilted at a dramatic 119 degrees. Both its north and south poles take turns facing toward the sun. Pluto is so far from the sun that its surface temperature averages a frigid 360 degrees Fahrenheit below zero. It is so cold that all the gases that make up Earth's atmosphere would freeze solid here. Pluto's highly elliptical orbit also produces some fascinating changes in its atmosphere. As it gets closer to the sun, the ices on its surface sublimate. That is, they change directly from solids to gases. These gases then rise, creating a thin atmosphere. As Pluto continues its journey away from the Sun, these gases then freeze and fall back to the surface as frost. As New Horizons turned to capture its departing images, we saw striking bands of blue haze suspended above the dwarf planet, showing tenuous layers of atmosphere just above the surface. These stunning blue layers are created by complex organic molecules scattering light at various wavelengths. Pluto isn't alone in its journey around the Sun. It is accompanied by 5 moons. Charon, the largest of these, orbits Pluto in just over 6 Earth days, the same amount of time it takes Pluto to make one full rotation. The same side of Charon is always facing Pluto. It is tidally locked to Pluto, like our moon is to the Earth. Charon is roughly as wide as France. At 1/2 the diameter and 1/8 the mass of Pluto, no other moon in the solar system is as large when compared to its governing body. Its surface is mostly made of ice. Charon's cratered surface is covered with ridges and canyons in the north and smoother geologically complex plains in the south. During its century-long winter, this mostly gray moon gets extremely cold at its poles. Methane, escaping from Pluto, lands on its surface and freezes solid. Radiation from space interacts with these deposits, creating the same thin reddish gunk we find on Pluto. Together, Charon and Pluto will continue their dance around the Sun for ages. Traveling 1 billion miles beyond Pluto, we are now on course to meet Kuiper Belt Object 2014 MU69. Nicknamed Ultima Thule, it was discovered in 2014 while the New Horizons team was using the Hubble Space Telescope to search for suitable targets beyond Pluto. As New Horizons cruised toward Pluto, Ultima Thule passed in front of a background star, thus blocking the star's light. This is similar to the way our moon sometimes eclipses the Sun. Astronomers coordinated their efforts to observe the 2-second event. With their combined observations, astronomers were then able to determine the approximate size and shape of Ultima Thule from over 4 billion miles away. Ultima Thule is a city-sized chunk of icy rock that orbits the Sun once every 297 years. New Horizons confirmed the overall shape of Ultima Thule with pictures taken during its closest approach. This flyby revealed more of Ultima Thule's secrets, such as the unusual flatness of its shape and its red coloration. Ultima Thule's color and orientation indicate it was formed in the Kuiper Belt and has been there its entire life. Within the Kuiper Belt, we find hundreds of thousands of icy bodies, a handful of known dwarf planets, and thousands of potential comets. The Kuiper Belt is vast. In 1992, an object named Albion was the first Kuiper Belt object to be discovered beyond Pluto and Charon, showing us the third realm of the solar system is more populated than previously thought. Since the discovery of this roughly 100-mile wide object, we have found many more objects in the Kuiper Belt. Orbits of most known Kuiper Belt objects range from 30 to 50 times Earth's distance from the Sun. However, a few objects are known to have wild, highly eccentric orbits. This collection of objects is known as the scattered disk. During the early days of the solar system, their gravitational interactions with the giant planets probably altered their orbits, giving them a scattered appearance. If we continue traveling 1 million miles a day through both the Kuiper Belt and the scattered disk, it would still take 300 years to arrive at the inner edge of the Oort cloud. Thought to be home to trillions of icy bodies orbiting the Sun, this giant region is spherical rather than disk-shaped and is trillions of miles larger than the Kuiper Belt. Now roughly 13 trillion kilometers from home, we have traveled about 1/3 of the distance to Proxima Centauri, our closest neighboring star. Out here, where the Sun's gravitational influence fades, is the outermost boundary of our solar system. While we have yet to make direct observations of the Oort cloud, simulations suggest that it is made of leftovers from the formation of our solar system. Further, the Oort cloud likely contains material from neighboring star systems, exchanged over vast distances and billions of years. If the orbit of one of the icy bodies in the third realm is disturbed by a collision or a gravitational interaction, it can begin a new life as a comet. Comets are small bodies made of ice and dust. They travel in highly elliptical orbits, bringing many of them very close to the Sun. Comets are divided into two categories: short-period comets and long-period comets. Short-period comets begin their lives in the Kuiper Belt and the scattered disk. They loop through the solar system on orbits that take less than 200 years. Long-period comets start their journeys in the Oort cloud. They have orbits lasting more than 200 years. The life of a comet can be perilous. Gravity from a gas giant can drastically alter a comet's path, often with disastrous results. They can be torn into smaller pieces, collide with a planet, or even be completely ejected from the solar system. Before a comet reaches the orbit of Mars, radiation from the Sun heats its surface, turning its ice into gas. This creates a fuzzy coma of water molecules and dust that surround the comet's nucleus. Solar wind and radiation from the Sun push some material away from the coma, forming the comet's dust tail and ion tail. As the comet gets closer to the Sun, the solar wind and gravitational forces can tear it apart. Those that pass too close to the Sun are destroyed. If the comet survives its encounter with the Sun, it will begin the long trek back to the outer solar system. The comet's tails and coma fade as it gets further from the Sun, revealing what remains of its icy core. Having completed its orbit, the comet will begin another long fall towards the Sun, until it is either destroyed or ejected from the solar system. For millennia, we have been fascinated with the sky above us. Our celestial neighbors, shining brightly in their travels across the heavens, are beacons that call to us, that compel us to understand more about our world and all that surrounds us. The need to understand has been vital to our survival as a species and will play a key role in the continued growth and prosperity of humankind. Only a handful of decades have passed since we first journeyed to a neighboring world, a journey that has since ignited the twin fires of curiosity and exploration deep within us. A journey that has spurred us to visit each major body of the solar system. We make these journeys not just for scientific discovery. We make them to satisfy our curiosity and to prove to ourselves that we are capable of extraordinary accomplishments. These journeys are a tribute to our time here on Earth and are the legacy we leave for future generations. We have finally reached the very edge of our solar system. But this is not the end. We will continue to explore. We will continue to push beyond the known boundaries and we will continue to discover what more lies beyond the edge.